Hey everyone, welcome back to the channel. So this video will be about what actually a database is, different types of databases, and what are differences between a relational database and non-relational databases. When should we choose one or the other? Now let's start with what actually a database is. So it is simply that where we store the data, right? जहाँ हम data को store करते हैं. And the second point is that it just doesn't let us store the data, it also let us access the data by using different query languages. So हर type जो हमारे पास database का है, they have their own database queries, right? For let's say relational is SQL. Okay? So it was simply a brief introduction about what a database is. So now let us go on to different types of databases. Now we classify the databases on the way that they store the data in them. Now first is relational databases. They store the data in table format, right? Examples there are MySQL database and Postgres database. Now if we talk about document type databases, they store the data in the document format, right? One example is MongoDB, the other would be DynamoDB, right? DynamoDB is actually in database which is in AWS. The most famous document type database is the MongoDB, right? The other type of the database is a key value store, in which we store the data in the form of a key and a value. Right? In document we have a document, and in that we have the key value. But in this we have a key and a value. This is how we store the data in this. And usually these key value stores are in-memory databases, and the example that we have is Redis, right? And they're used majorly for cache systems. Now the other type is graph. The major example for that is a Neo4j. So again, in graph-like databases, how we store the data is we have a node that is actually connected to a different node, and this in turn could be connected to some other. So that is how we store the data in the graph. Okay, now let's go into the differences between a relational database and a non-relational databases. Usually this is a question that will be asked in every single backend interview. So first point is that if we have a one-to-one mapping, or if we have a many-to-many, but not that complex, we can actually use a relational table. So it is more better to use a relational than non-relational. Now, if we have one-to-one actually data, or we have one-to-one data, we can use actually a non-relational database. In that scenario, it will be more like a document type or a Redis, right? If we have a complex many-to-many, let's say in Facebook we have one user is connected to many users, and those users are connected in turn to different users. So that's a complex many-to-many relationship. In that case, we can use graphs. Now, the second point that we have is if we want transactional guarantees, right? Like ACID. In ACID, we have 4 of them. That's what we have. If we want a transaction to be atomic, if we want them to be consistent, if we want to be durable, if we want to be isolated, right? I will create a different video on what ACID is. So let's talk about this third point, that's schema restriction. In relational databases like MySQL, what we have to do is we have to add a new column, right? We have to alter the table and add a new column before we add any data type. But in the non-relational tables, we can actually add any different data type in real time. So it could be an object, be a string, it could be a number. It doesn't matter. But in relational databases, we have to first define it and then we can use it, right? Now, let's talk about the fourth point. So in this case, we have what I said is alter tables is expensive and can cause downtime. So let's actually go into a little bit more deep into what it means. So let's say we have a table this is let's say table of users. Now this user could have actually multiple different informations. Let's say we have, let's say, already existing 10 rows in there, right? We already have 10 rows. हमारे पास 10 rows है. Now we want to add an extra row, right? We want to add an extra row. Let's say we want to add an age of this particular user. Now let's see adding this column. What internally database does to do this? So as we know that all the data that this is stored in the disk, right? Now in disk, what we have, let's say this is the whole disk here. I'm not going to draw that. Like this is the whole disk. In that, the data is stored in multiple pages. This is, let's say, one page. This is another page, and this is another page, right? Now this data, this is all of them, and their rows are stored like this: one row, second row, third row. Now these are actually, now pages are of fixed size, and the rows inside of them are again of fixed size. I'm not going to go into much depth into it right now. I'll create its own video how this is actually stored in the database. The problem here I'm going to discuss. The problem is that if we have to change or add, let's say, any new column into this one, we have to change every single row into this, right? And even if that was not the case, if we have to just change one value in a one page, we need to rewrite this whole page. That's how things work. If we have to change one thing in a page, we have to rewrite this whole thing. And now, because we have to change we have to add a new column. We have to make the changes in every single page wherever the data is being stored. So for that reason, we had to rewrite these whole database. They have these whole pages in the database. That causes sometimes downtime of the database if we have to alter a table, and that's kind of a huge cost for editing the table. So that is one of actually the disadvantages of relational databases or non-relational databases. So we completed first one, we completed second, third, and fourth. Now let's move on. Better join support. Now, like it is, I think, commonly known that relational tables are better at joining things because they have to support relational databases. They have to support one-to-many, many-to-many relationships. So for that reason, join supports in relational tables is better than the join supports in non-relational tables. Now, there are databases that are actually supporting joins these days, but it's still not as good as actually relational tables. Okay, now we have the sixth point. Now, non-relational databases are better at localization. Now, what do I mean by better localization? So let me actually show you that. Okay, now say that we have two kind of entities. One of them is user, another is its transactions. So user's transaction, right? In relational tables, how we will do this? We'll create a different table for user. We'll create a different table for transactions. Now, in non-relational databases, now if we access these two frequently together, now it is preferred to put them in the same document. So what we're gonna do in non-relational is create one document and put user details over there, and there probably create a transaction field. In that transaction field, we will have all the information of that particular transaction. So the database, what it's gonna do. Let me say this is a disk. Now let's assume for now that we don't have an indexism. So let's say we're accessing the data from the disk directly. So how it is going to be different in case of a relational and non-relational database. Now this database, what it's actually going to do, it's actually going to get the user's data, which is in somewhere else, like in a different page, right? And then combine it with the transaction data, which is in a different page. So it has to do two disk seeks, one for this one, the other for this one. Right. Now, if we talk about non-relational databases, in that what we have to do, the database has to only do one disk seek normally, that it has to go into a page. In that particular page, we'll have both the user information and also the transactional information over there. Right. So in this case, now this is what is called better localization. So it is the data is actually at the same location kind of, right? That's what we have. So for this reason, queries in non-relational tables actually are much faster than non-relational tables because we have to do joins in them. Okay, now this is also done. The next is that in non-relational tables, what we have is we can store multiple versions of the same data. So it's possible that in one of the document, the data has totally different structure, and the other document, the data has totally different structure, right? Because we can change the data in the real time. We don't need to kind of define the structure first before kind of adding the data. But in this case, the data has to be of the same kind of format. All of the data will have the same format. It is possible that one of them could be, let's say, null, the column. Let's say we define a new column and all of the values are in the start is null. But again, the structure is the same for all of the rows. It is not kind of different for one and the other, different for other. Okay, so these are all the differences actually I can point out right now. So bye, thanks for watching the video.